Okay, so we've looked at converting from scientific notation to decimals, and then we've looked at converting decimals back over to scientific notation. How do you add, subtract, multiply, and divide numbers in scientific notation? How do you work with them? So I've got kind of a simple example. Adding and subtracting, you can treat the same, as well as multiplying and dividing, you can kind of treat that the same. So I'm just going to give an example of subtraction and an example of division, as far as how you begin to work with scientific notation. So let's look at this first example. So this is example 147. This is on the HIV virus infecting human CD4 white blood cells. So this is the diameter of a CD4 white blood cell. So that's the host blood cell that the HIV virus infects. And this is the size of the diameter of the HIV virus. So you can see that both of these sizes, these are in scientific notation. So the question is, how much smaller is the HIV virus than the cell it infects? So to figure this out, we need to take the diameter of the white blood cell and subtract from that the diameter of the virus, and then that'll give us our size difference between the two. So the diameter of the white blood cell was given up above. That's 4.80 times 10 to the minus 6. And then we're going to subtract the diameter of the HIV virus, which was 1.20 times 10 to the minus 7. And then that'll give us our size difference. Now, in order to add or subtract two scientific numbers, this second part, where it's 10 to an exponent, the exponents have to be the same power. When the second part of the scientific notation is the same power, then you can just add or subtract the a's in each of the scientific notated numbers. But you can see here, one is 10 to the minus 6 and the other one's 10 to the minus 7. So how do we get those to be the same? So there's a little algebraic trick you can do to make that happen. And this is a property of exponents, bases and exponents. So you may or may not remember, but let's say we've got two powers of 10. So we have 10 to the x power, that's being multiplied by 10 to the y power. So when you've got bases that are the same, and you're multiplying two bases that are the same, then it's going to be the base, and you just add the exponents together. Okay, so 10 to the x times 10 to the y is 10 to the x plus y. So you just add the exponents. So what happens when x and y look something like this? So we have 10 to the positive 2, and we're multiplying by 10 to the negative 2. Well, this will be 10 to the 2 minus 2, which is 10 to the 0. And 10 to the 0 is just 1. So when you multiply two bases of 10, kind of like equivalent exponents, except one is positive and the other is negative, that's just going to be equal to 1. And, when you multiply any number times 1, you just get that number. So, multiplying something by 1 in mathematics is a good way of converting something into something else without changing its original value. So how this idea helps us here is that we would like to make this 10 to the minus 7 become a 10 to the minus 6. So how do we get that to happen? So we've got 1.20 times 10 to the minus 7. So if we could multiply this 10 to the minus 7 by 10 to the positive 1, okay, negative 7 plus 1 is negative 6. Okay, so this will give us are 10 to the power negative 6, so that we can now add this second, this diameter of the HIV virus, and we can subtract that from the diameter of the white blood cell. I'm sorry. But we can't just go about multiplying one side by 10. We can multiply it by 1, though. So we've multiplied this side by 10 to the positive 1, which means we can just multiply over here 10 to the minus 1. And so 10 to the minus 1 times 10 to the positive 1 is just 1. Okay, so multiplying these two together, this will be 10 to the minus 6. And multiplying 1.2 by 10 to the negative 1 is going to move this decimal point over 1. So this is going to be 0.120. And that's going to be minus 4.80 times 10 to the minus 6. So now that we've got both numbers that are in scientific notation with the same power of 10, then now that clears the room for us to just subtract these values of A. So now we've got 4.8 minus 0.120, and that's going to be times 10 to the negative 6. And 4.8 minus 0.12 gives us 4.68 times 10 to the minus 6 meters. So that's our answer. So before you can add or subtract scientific notation decimal numbers, the powers of 10 have to be equal. And so this is a little trick on how you can do that and keep everything straight. Okay, now what about multiplying or dividing? When you multiply or divide, do you have to worry about that? Do not. So let's look at this other kind of sensible question here. Part B. So how many times larger is the host cell compared to the HIV virus? So to figure out how many times bigger the white blood cell is than the virus, then what we're doing is we're calculating a scale factor. And a scale factor is a ratio between the size of the white blood cell versus the size of the virus. And so the diameter of the white blood cell was 4.80. Put that in still. 4.80 times 10 to the minus 6. And that's going to be all over 1.20 times 10 to the minus 7. Okay, so we don't have to, in doing multiplication or division, we don't have to worry about converting these to the same power of 10. Okay, instead, we need to use another trick dealing with exponents. And that trick is that when you move a base to a power from, for example, the denominator up to the numerator, okay, what you do is you change sign the exponent. Okay, so this is going to be 4.80 times 10 to the negative 6. And if we move this 10 to the minus 7 up into the numerator, it's going to become 10 to the positive 7. And we still have this 1.2 down here in the denominator. Okay, so just doing one thing at a time. So we have 4.80. Now what happens if we multiply 10 to the negative 6 times 10 to the positive 7? The bases are the same, so we add the exponents. And so negative 6 plus 7 is 10 to the positive 1. This is all over 1.20. So if we take 4.8 and we divide it by 1.2, we get 4. And so that's going to be 4 times 10 to the 1 power. And 10 to the 1 power is just 10. So 4 times 10 is 40. So 40 is our scale factor. That means that the white blood cell is 40 times larger than the HIV virus. Okay. So, that's how we deal with adding and subtracting, multiplying and dividing a scientific notation. So here's a think, pair, share. And this is dealing with the COVID virus, which we've become familiar with. So let me give the answer to both of these sections, and why don't you give it a try yourself and see if you can figure this out. And if you have any questions, just let me know. So the answer to part A should be 8.92 times 10 to the negative 6 meters. And the answer to part B should be a scale factor of 112.5. That should be your scale factor. All right, give that a try and let me know how you do.